All right. Hello there, ladies and gentlemen, boys and girls. Welcome to VUX World, the podcast that brings you the very best and brightest minds in the fields of conversational and what they do so that you can do what you do better. Hopefully, as I'm sure you will, as I'm sure I will, because I always do. And I'm excited to be joined by Kordel France, who is the CEO of Seekar Technologies. Welcome.
Thank you very much for the opportunity, and thank you for having me on the show. Excited.
Yeah, it's an absolute pleasure. Absolute pleasure. I'm glad for you to join us. So, where you've been in Dallas, is that right?
Yes, sir. Dallas, Texas.
Nice. And Texas is yeah, not that, but it's going through this kind of like hotspot, isn't it, for various technology startups? Everyone seems to be flooding into Texas at the moment. What is it about Texas that is driving more people and more technology startups and whatnot to the area?
Yeah, so Austin, Texas has gotten really, really hot, and Dallas is actually kind of absorbing a lot of that demand as well. And the reason that it's kind of growing so rapidly in the tech domain is for a few reasons. It's the cheaper cost of living. So California is a bit, Silicon Valley is a little bit tough to live in, and some of the other really high tech or cities that were known for their high technologies have a higher cost of living. No income taxes in Texas. So some of these things kind of have facilitated a little bit of a migration in that sense towards these areas. And I think that there's been some enticements for businesses to start and relocate here as well as at a legal level. So there's a lot of talent that is also available, and it's creating some pretty significant opportunities. It's really cool to kind of watch it materialize over the last few months, and to see how it's really getting quite hot for tech.
No income tax. So you earn your taxes. Is that
at the state level? No.
Interesting, right?
Yeah. There's a few states in the United States, and Texas is one of them.
Right. Wow, that sounds good.
Yeah. It gets you on a few other things like really, really crazy property taxes and stuff. So sometimes it kind of negates it. But that's a pretty good enticement for a lot of people that are, especially young people, trying to start a career in tech.
Yeah, definitely. So are you from Dallas, or did you kind of migrate to that at some point?
So I migrated here. I actually grew up in Idaho and Utah in the United States, and started off there. Did my undergrad there, and ended up migrating this way towards after I was in the industry for a while, and pretty much been here ever since. It's a good place. I like it. Really flat, but I like it.
Just moved to a quaint little spa town near London called Tunbridge Wells. Another quaint spa town, it's called Harrogate, and Tunbridge Wells is like this, like that. It's one hill after another. You go for a run in Tunbridge Wells, you could run 5K and feel like you've run 25. Harrogate is a total opposite.
Oh, wow.
Is totally flat. I went for a run this morning, and I'm looking at the elevation gain. I climbed a grand total of 19 meters in about 30 minutes. So it's definitely flat. So, but it's better for running, I see.
Isn't that interesting? Like I would have never thought that I would have missed mountains and elevation changes when I first moved to Texas. But like that's something I look forward to seeing whenever I go back and visit family. It's interesting.
Yeah, it is crazy. It's crazy. So tell us about Seekar Tech then. Seekar Technologies. What is it, and what is your aim? What's your mission? What is it that you do?
Sure. So Seekar Technologies is an artificial intelligence company that's aiming to really kind of democratize AI in a couple of different respects in which you really see other companies today. So we have an emphasis on making AI mobile. So really an emphasis on edge computing, making AI explainable so that we can kind of get away from the black box approach, and also making AI ethical. So really a heavy review of our data sets, having industry leaders come in and actually work with the engineers on the data sets we train our models on, to really kind of add another level of oversight so that we can rectify bias in a lot of regards in our AI models. All this comes together to really address some industries in which aren't receiving a whole lot of attention or as much attention right now as some other really prominent industries, such as self-driving cars, smart home assistants. There's a lot of heavy investment as far as capital goes and research in self-driving cars and other regards, such as smart home assistants. But other domains that maybe aren't receiving such a heavy amount of attention, such as agriculture, maybe manufacturing, some aspects of medicine, that's where we're really trying to focus on and really trying to emphasize our technology for. Because again, we're trying to democratize AI, right? Trying to get it in the hands of everybody, because there's such an incredible amount of potential that we haven't really even tapped with artificial intelligence. And if we can kind of get it in the hands of a lot of these other industry players, it really accelerates the pace of development in several industries instead of the select few. So we've most of our technology kind of has a focus in some of those, we call them disadvantaged industries.
Interesting. Shout out to Shout out to Paul Kutzingers. Is people. Hello, Paul. Nice to have you along. Pleasure. So tell us why. In fact, actually, before we go, tell us about. So is it like a platform that folks in the agriculture sector can get a hold of and build conversational solutions? Is it a technology that you have the scenes where you do the design, build, implementation? Like, what if someone was going to acquire some services from Seekar, what exactly would they be getting?
So our primary product is an API that actually it accepts multimodal sensor data. So we can accept microphone data for natural language processing. We can accept camera data for computer vision applications. We can even go in as far as accepting radar data. And so we really have a platform that has all these knobs that we can turn on or off, that allows you to either process them in parallel, as some applications I can discuss in a moment, or something as simple as I just want a natural language processing application to facilitate for a conversational bot, or another different type of automatic speech recognition application or something like that. But it's really an AI platform that hosts computer vision, natural language processing, advanced signal processing, and some other regards, that we are trying to kind of make it as a package solution that you can use in these different industries to be able to really achieve some significant outcomes to some hard problems. So it's effectively an API.
Interesting. What's on disadvantaged, as you call it, disadvantaged industries, and what is it about your culture, manufacturing, medicine? What is it about those industries specifically that kind of drew you towards that as an area of focus?
So before we started at Seekar, my co-founder and I, we every time we said a headline about artificial intelligence, it was always in self-driving cars, or it seemed to be like in the same three industries, right? And it's like there's a lot of these solutions can be applied to other applications, other industries that maybe aren't really fluent in artificial intelligence. And so we did a little bit of research before we actually started the company. And for agriculture, for example, a lot of people we talked to really didn't understand artificial intelligence and how it worked, and really, how it could be used in their specific domain. And so after kind of explaining to them, hey, this is what it is, this is how you can use natural language processing to kind of help facilitate better outcomes in your regard, in your company, the light clicks, right? They light up and they get so excited, and they start to see all the potential and all the opportunities that they can facilitate with these solutions. And they start gaining kind of a relationship with us, and we start developing products for them, and it kind of expands to other players within the same industry. And so that was pretty appealing. Is one is kind of again democratize, but also promote awareness about what AI actually can do for other industries. Another thing is my partner and I came from a Department of Defense, and a lot of the reason that AI hadn't been heavily used in some solutions within the Department of Defense is for a few reasons. The first reason is because the consequences of an artificial intelligence model being wrong are very severe, right? Because if you're using this in a very sensitive setting, and this goes for medical applications as well, if an AI model is wrong, it could cost lives, right? So the consequences are very severe. Secondly, a lot of these AI solutions aren't explainable. So if we have a neural network that is processing data and it outputs a classification, it's really hard to go back through and see, or it was really hard to go back through and see why it gave an incorrect classification. So why was the model wrong? We saw there was a need for making explainable solutions that we can go back through and say, okay, I know the exact group of neurons that facilitated this incorrect classification. And how do I tweak this accordingly? Or seems to be a high amount of bias and a high amount of weight over this group of neurons or in this part of the algorithm. How do we rectify that? So we took significant effort in actually building out an explainability feature with our products so that we can, the engineers can understand where they went wrong or how we can retrain the model, and B, the customer can know, where's the issue? Is it on our end? Is it on a usability end? Is it on an algorithmic end? Why did we not get the outcome we wanted? And we saw this as an opportunity to really garner trust with some industries that are apprehensive toward using AI. So, for example, medicine, right, and in defense. So by implementing this explainability feature and also kind of really trying to shoot for marginal increases in improvement. So by saying we can augment a physician's or a surgeon's capability of being able to perform their job 10% better or 10% faster in surgery or in some regard, that's a pretty realistic achievement, right? Instead of coming in and saying, we're going to half the time of a surgeon doing his job, and we're going to make it 200% better and 300% better. These are pretty lofty increases in which you're kind of over-promising and under-delivering, which we saw a lot of artificial intelligence solutions doing. So by shooting for a smaller marginal increase and building on top of that, it's actually worked quite well, and we've been able to kind of garner a lot more trust between industry partners.
Interesting. Going into some use cases, examples and stuff, but Paul's got a decent question, which I think is relevant to the track that we're on. Paul, I know you mentioned that my mic is a bit flaky. Apologies if my mic is a bit flaky. My internet signal is going and going at the moment. I've been in this house for a grand total of about 8 days, and still in bedding in period as far as the internet goes. So hopefully it will improve. But Paul's question is around. It's really a question. It's comment around the ability and explainability of this seems to be a great feature. Perhaps let's dive into that a little bit more. You mentioned there's explainability features for developers, for users. I'm wondering if you can give us an example of this explainability engine. Perhaps actually you can combine the two. Let's give us an example of a use that is out there in practice, and then how the explainability feature wrap around that use case, if you don't mind.
Yeah, absolutely. So the principle that our math teachers taught us in school comes back to haunt us here, right? Always show your work. Why did you get the solution that you received, right? I hated this as a kid because I did pretty well in math, and a lot of the times I just do it in my head and put down the answer, and then I would get a bad grade and not understand why, right? Show your work. We got to show our work. So we took that approach with our artificial intelligence API. So if you can imagine. Let's imagine a recurrent neural network that's acting in a natural language processing application, right? So we're going to have a series of a time series of data, an audio waveform that's going to be monitored by this neural network to try to either predict, what it's saying or try to determine some pattern in it to help facilitate a question. So we have this host of neurons. Anyone who is not familiar with the neural network is it's basically a neuron as a mathematical function to some regard, and an algorithm feeds data into this host of neurons. Sometimes they're on the orders of thousands or hundreds of thousands or millions, and to be able to kind of help solve each take a small problem or recognize a smaller pattern within the overall larger sequence to try to kind of come together and realize the significant pattern you're looking for. So we actually track the neural pathway throughout this neural network. So being able to assign identifiers to neurons and say, okay, I see that when I received this audio transcript, it went through the neural network, and this is how it was processed. And you can actually see which neurons were activated, which neurons weren't activated, and kind of be able to facilitate, say, okay, I see that it was wrong here, or it was wrong over this group of neurons, but it was correct over here. And you can kind of have more insight in how to either retrain the data, or insight in how your algorithm is actually biased, right? Or your data set could be biased. Now, if you have hundreds of millions of neurons, this is a pretty hefty task, right? Because you don't want to have to sift through every neuron to see if it was fired and which group were fired. So we had to get kind of clever on how we cluster neurons and how we understand which ones were activated and which ones weren't. So this is at a very technical level. And if you take this, the user doesn't actually want to see this, right? They don't care about which neurons are fired. They care that their algorithm was wrong and why it was wrong or why it was right. So we had to go a step beyond that and create a explainability report that a user can actually interpret, so they can understand. Okay, hey, we see that this part of the algorithm might incorporate some bias. We're going to send some data back to the engineers so that they can retrain it, or we need more data regarding this certain type of outcome so that we can rectify this part of bias within the model. So we're really trying to build this explainability feature out to kind of meet the needs of clients and customers, but we're trying to build it so that it can actually it can explain its responses just as a human can, right? If you ask a doctor what's wrong with a patient, they can explain the reasoning why in a very prose form, in a very human interpretable form. If we're going to garner trust within some communities such as medicine and defense, and we're going to actually have AI provide solutions in these regards, a lot of the users expect the same, right? And if they're going to provide solutions that have very, very high consequences, we need to know when they're wrong and why, so that we can actually make progress in this regard and actually, live up to the promises that we're making and how accurate these AI detection systems are. So I'll pause for a moment. Are there any questions regarding that? Does that make sense as far as the report goes?
It makes perfect sense. The one thing where there's a gap in my understanding isn't necessarily around ability and being transparent about what the model is doing and trying to locate the source or the cluster of neurons that are the culprit, so to speak. The thing I suppose I would like to learn a bit more about is how you take that and draw out the conclusion that it may be a bias. So where does because for example, a bias, maybe we're talking about different types of biases. I'm referring to a bias around perhaps it recognizes men more than perhaps recognizes American English over people with a Spanish accent or something like that. But is that the kind of bias you're searching for in this? And if so, how do you attribute the activity that you're able to find, or the issues that you find in the neural network? You attribute that back to a problem bias and not just a problem with some other in the understanding?
It's a great question. So there's a couple different ways in which we address this. So we actually pre-process the data in some regards to actually determine, okay, for example, in a speech application, can I even recognize anything that the person is saying, or is this a language that I am entirely not trained on, right? Or is there a lot of background noise that needs to be filtered out, or can the microphone even understand anything of an English sentence, or something like that? So there's like a more of a rule-based, non-AI pre-processing algorithm that goes into play before it is even fed into the AI, that kind of tries to do some error mitigation and say, okay, these are the issues that I've encountered so far, and try to relay that back to the user. Now, it sounds simple, but there's quite a bit of complexity in that, because each domain has a bit of different has issues that you may or may not be able to or that you have to adapt the API for, or that you have to account for. AI or natural language processing has different issues than computer vision processing will, right? And on top of that, we've also got to, before we even deploy an application, we have to train the application with the users. So if you're familiar with transfer learning, or live model updates, federated learning, anything like that, we basically have a lot of our solutions are mobile, right? So we've got mobile applications that are associated with them, primarily for this purpose of providing additional explainability and bias mitigation. So a user will be able to actually provide feedback on whether the classification was right or wrong. So if it was wrong, we can send this back, and it actually the model will autonomously go back and adjust the weights of the model, and kind of update itself. And if and it will do the same thing if it's correct as well. Now, the user in a real world scenario, you don't want to do this, right? You don't want to have to go back and input your whether or not the AI model was correct or not, because what's the point of having the AI model? So we have this pre-training that we actually do before we deploy it, where in a live scenario, it's going back and being updated by actual users in the application itself. So this helps kind of be able to identify where some weaknesses are in the model. If it's not picked up by a pre-processing, that rule-based system, then we know that it might be something within the algorithm, and we can go back and actually see, okay, there's significant, this group of neurons is significantly used higher than this other group of neurons. Why is that? Why is a good neural network will attribute weights across the entire neural network so that they're effectively all used. And if you have only part of it that's used, then you should retrain, or there's obviously some bias in the system because it's using the same neural pathways over and over. So this kind of helps rectify that, and that we can actually determine if we actually have a really uniform, unbiased training system. On top of that, before any of this even starts, before we even go into to develop a neural network or an AI application, we look at a data set, right? And we have industry experts come in and review the data set such that they're actually looking for holes in gaps that we may have missed to make sure that it's well-rounded. So if you're familiar with any facial recognition, news and facial recognition, there's a lot of concern right now because it incorrectly provides responses to some demographics over the other, and that really comes down to your training set, right? If you have holes in the data, and if you have unequal proportions of weight, then it's going to provide, it doesn't matter how good your algorithm is, it's going to provide biased results. So by having critical and really meticulous review of these data sets beforehand by engineers, by industry leaders, by people that may not even have any skin in the game, but have a mindset of more of an ethical mindset on how to incorporate data into the algorithm and really account for all aspects of the domain space, then you were able to kind of rectify a lot of the biases before it even touches the algorithm. So there's a lot of heavy lifting that's done beforehand on just looking at the data set to make sure it's very representative of the population, statistically at least.
Yeah. And is this stuff something that you do every single time you work with a new client, or is this something that you've already done and continue to do kind of behind the scenes core technology perspective?
Yes. So yes and no. For example, if we're using let's say a client comes to us and they want a body detection system, just skeletal tracking for whatever reason, right? Let's say we've trained skeletal tracking on for a sports application, and the client just wants a skeletal tracking application for security. We can leverage a lot of that same data in between both domains because they're likely going to be the same unless the customer has a really, really specific purpose which they want to try to identify within skeletal patterns. If we have an entirely new domain that we haven't ever trained anything on before, then we do encourage going through this process with our customers because it's our ethos of why we started the company, and it's our founding principles. It is a bit cumbersome from someone who just kind of wants to be able to download an AI model and have it work and go, right? But we can promise additional accuracy, and it really kind of rectifies and help a lot of these biases, and helps emphasize the ethics behind how we're building our models. So by taking a few extra days or a few extra weeks even to review these data sets and provide a very accurate solution, these customers get results that they might not receive elsewhere, and also get solutions that they know are very representative without any lurking variables within the data.
Interesting. So you mentioned skeletal tracking there, and I know the outset you mentioned around explainable AI in a kind of general sense. You mentioned conversational AI, that kind of like body movements and image recognition and things. What kind of relationship does that side have? It sounds pretty between lines, obviously, you've got immense capabilities, the whole concept of AI and building AI models and machine learning models and neural networks. I imagine that the same principles apply whether you're building an NLU or you're providing something for image recognition or something like that. So what Seekar does is kind of in that conversational space versus broader application technologies.
I would say at least a third of our data or a third of our application is in the conversational space, or at least the natural language processing space. We've done a lot of NLP in medicine, and we've actually used a lot of NLP practices to leverage that in agriculture. So we've actually used those applications to provide insight in how an engine is working in some regards. And it sounds crazy, but I can talk about that in a moment. But the one thing, like, in order to build like a speech recognition application, you really have, or a natural language processing application, you really have automated speech recognition, right? So being able to actually partition what a person's saying and put that into words. And then you have to go through you have that recognized speech. Now, what is it actually saying? So I'm trying to find out who went to the store. And I have a series of words that came in that I partitioned and I recognized. I'm trying to figure out who went to the store based off of that string of words. So being able to provide that part, the NLP part, seems to be a lot more, or has been a lot more difficult for us to implement, just because of the different domains we're in, versus the automatic speech recognition regard. It seems like there's a lot of good ASR applications out there that seem to, have solved a lot of problems. In background noise, we've had some that seems to provide the biggest issues as far as ASR goes, just filtering out background noise. But even then, there's been a lot of great tech that's come out that's kind of rectified that. But I would say about a third of our tech is in natural language processing.
And do you from a kind of, it's interesting to speak to someone who is proficient in AI models and technologies. Most of them, we speak to people who purely specialize in speech recognition, for example. Last week, Andrew Richards of SoundHound, more or less like that conversation about filtering out background noise, being back in for mic placement around ASR. But it's interesting to someone who has expertise in a lot of different AI kind of spaces. I'm wondering whether for Seekar, do you actually differentiate from project to project between types of AI applications that you're creating? Or do you see one in the same? Like, if that skeletal tracking thing, do you approach a project like that in the exact same way as you would approach a project that requires speech recognition? Like, do you differentiate? Or is it all a form of the same thing, as essentially is just it's AI and machine and models and neural networks and such forth?
So we approach them all projects in the same manner as far as the explainability parts and kind of analyzing the data set beforehand goes. But we've effectively tried to build the trunk of a tree that we can say, okay, our API, we don't have to recode a lot of the trunk. Like, we can use that, whether it's computer vision, whether it's natural language processing, reinforcement learning, whatever that might be. We can take a lot of that and kind of, pipeline different processes out into different branches. So in a natural language processing application, we are able to utilize part of the trunk, but it's got its own branch of the API that is explicitly devoted to NLP. Now, we're a startup, right? So we're still trying to gather a lot of different, intelligence in different domains, so that we can make this natural language processing branch incredibly sophisticated, right? So that we don't have to, go back and code specific solutions to different problems. We're making it very general. I have a personal desire to really create a generalized AI in some regard that can be used in different applications without having to be recoded or recoded significantly. And if it does, it's able to be, retrained rapidly. So setting up the infrastructure for that is really key, and we've leveraged that across all domains. But a lot of our customers, especially within these applications in these disadvantaged industries, they come with very specific needs. So there's when we started out, there was a lot of time really developing features that accommodated these specific needs. But over time, we're able to kind of re-leverage and, and repurpose a lot of that into other domains. So as an example, for our first few medical products that we did a natural language processing application, and the first couple were very specific, and we had to really code a lot of the features, by like hard code a lot of the features, because we didn't have enough domain knowledge to actually make a general model. But as we learn more and as we develop more and more applications, we're actually able to leverage the code and the API previously built for the next customer and the next customer and the next customer. And so we don't have to actually recode anything. We can just provide it with training data, and it actually outputs the result we want. So as far as the trunk of the tree goes, I think that we utilize that for all of our customers, and then we branch out to, if we have to develop a specific application, we definitely have the capability to do that. But we're trying to build a more robust platform that doesn't need significant time investment to be recoded for new customers.
We have a comment from Danny, who says, "Great content, Kordel France." I would second that, Dan Ashry, definitely. So
thank you.
You were talking there about the NLP in the medicine space. I'll begin that later in terms of your future vision for that general AI and what it would take from where you are now to get there. But I think while we're on the NLU, you had a few decent examples. You're on about checking on engine performance using sound. I think last time we spoke talking about lie detection, speech recognition. I wonder if you can just maybe share a few of those other kind of examples of how you've applied some of this technology in areas that a lot of people who choose the podcast usually would think of it speech recognition for being used purely to process text, or sentiment analysis or something like that, to be used in a conversational application. You're applying it to a few other interesting use cases. I'm wondering if you could expand on some of those.
Sure. So the lie detection portion, I'll address that in a moment. That actually goes into part of our medical application we built. For agriculture, we use natural language processing in a little bit of a different manner. So if when you're doing any language is really recursive, right? If it's really spoken in a prose form, if you have a subject and a verb and a direct object. So I went to the store, right? I went to grab apples or whatever, right? You have this really recursive subject, verb, direct object, whatever, over and over and over again. And the natural language processing model is really looking through this cycle to try to extract meaning about what's happening. It's looking for a pattern in something. So we took that concept and we actually applied it to detecting anomalies in engine performance for the purposes of agriculture. So I grew up on a farm, and a lot of the times we spent broken down fixing things was on engines, right? Because the engine performance was we didn't catch the maintenance, or we weren't able to catch the problem of the engine in time before it actually broke and cost us significant time and financial investment to fix. So in addressing that, you can an engine runs in cycles, right? So you have a 2-stroke engine and a 4-stroke engine, and they're going to run in the same cycle, and they're going to produce the same audible pattern for the most part, unless there's something wrong. And you have different RPMs of engines, right? Which they're going to sound slightly different, but they're still going to produce the same type of underlying pattern. So if you imagine a natural language processing system that is identifying subject, verb, direct object to try to understand the meaning of that sentence. And if it's, let's say in sentiment analysis, if it's positive or negative, you can apply that same thing to an engine cycle. So we have the upstroke of a 2-stroke engine and a downstroke of the 2-stroke engine, or a 4-stroke engine, whatever it may be. You have the different sounds of an upstroke and a downstroke to that the natural language processing model can go through and say, okay, positive. It's positive sentiment, meaning it's positive performance. Negative, meaning something's wrong. I need to look at if it is wrong, what's wrong with it? Is it the crankshaft? Is it a bearing in the system? Is it a blown spark plug? What is it? Something that we can actually drill down and say, out of the plethora of problems that could possibly be wrong with the engine, these are the most probable 2 or 3. So being able to apply that to an engine and have it just listen, to have a microphone listen to an engine over time to see, okay, this is nominal performance, this is nominal performance. Oh, I found something that wasn't nominal, right? It's actually proved quite well. When we're driving, right, even in your car, if you hear something wrong, you usually have to have the music down, or you can't be talking on the phone, or you might even be paying attention because you're trying to actually get to your destination. So sometimes you might not even hear what's going on. But if you have something that can filter out the background noise and is actually focused on just monitoring engine sounds, right, then you might actually be able to provide some predictive maintenance. So we've started with this principle in agriculture to actually try to provide an application that works. And the gentleman you spoke to last week provided some excellent insight on background noise that I wanted to really emphasize on how you filter out and how important that is, because it's really, especially in an agriculture environment, you have all these sounds that might be around you, and you have to filter everything out that isn't the engine of concern, and really focus on that engine, and then apply the NLP model in that regard to actually look for those anomalies. So it's kind of a unique application, but it's worked really well so far.
And something that applies well beyond, obviously, I mean, it could be applied in airplanes, trains, cars, you name it, absolutely anything. Obviously, the challenge with that becomes just drive them. Cultural, maybe they're in a field on their own, whereas cars are surrounded by other engines and other traffic, so you might get some challenge there. But broad application with all of this, is that something that you look for when developing these kind of solutions, building it into broader applications, or are you fixed on solving that one problem for agriculture, and if it does scale beyond, then
yeah, so we definitely look into the future on how to incorporate this at scale, right? So we started with agriculture just because it was an easy vehicle. It's something that we've addressed before, and fits the domain of that disadvantaged or the definition of that disadvantaged industry that we spoke about earlier. But you can definitely use it for different types of engines, airplane engines, right? Predictive maintenance at an airport, car engines, right? The biggest issue that we think of at scale is being able to really focus on one engine over the other and filter out that background noise, because you have to be able to filter out conversation, filter out other engines, filter out any other chatter that's going on in the background in order to use this. One thing that actually has that has been really advantageous in addressing some of these problems is turning sounds into spectrograms. So instead of the time frequency domain, we turn sounds into images into the time frequency decibel domain. I think or amplitude frequency decibel domain rather. So with this, you can use a convolutional neural network. It's image processing, it's image recognition in a natural language processing application. So wow. It's quite interesting, and it works really well. There's a lot of papers on this you can research and find, but you're using computer vision for sounds. It sounds nuts, but it is crazy, and it works really, really well.
Yeah, it does, because anyone who's had any experience with digital things, like making music or editing podcasts or editing video or anything like that, I've probably come across these kind of I actually use times with the podcast. What I tend to do is I audio, and I apply a EQ. You've got a good mic, so this obviously won't take much touching up, but sometimes people have just got their built-in laptop mic, and when you compress it and fill the volumes, it just sounds terrible. So you need to apply EQ, count those horrible frequencies, and sometimes there's just this little noise that I hear and I can't identify it, and so sometimes I'll use that spectrum analyzer just to see if there's a little spike, and then I'll hone the EQ there to see if that's it, and quite often it works. So sometimes those can be used in music production, but I've never thought about using that in NLP, because if you can get that analysis right, you could probably use speech recognition, kinds of stuff.
Yeah, it's interesting because a lot of natural language processing approaches to solving problems can be used in other domains, right? And really language is a sound. It's a very unique sound because we all speak differently and we all speak in a different manner. We all have we have different dialects, different accents, different languages even. But it's really it's just looking at sounds and trying to derive a pattern of information from them. So you can apply those those approaches to really anything that you're trying to find a pattern in sound with. You bring up a really good approach, or a really good topic I want to touch on, which is kind of trying to filter out things in the microphone that you can't figure out where they are. One of the issues we see at scale, and what we're trying to figure out, is how much can be rectified with software and how much needs to be rectified on the actual design of the microphone. So is it a mechanical problem or is it a software problem? It may be that in order to find certain patterns for certain engines, you actually need a microphone that can detect a different level of frequency than the one that you're actually using, right? Because not all microphones can detect all, the same types of frequencies. But that's something that, we might have to get into, is actually developing a custom microphone for some engines in some regards. But yeah, anyone that's interested in kind of energy conservation and really implementing that effort this is a good application that can really save a lot of fuel in a lot of different regards, providing preventative maintenance.
Interesting. Yeah, with the microphone technology, I mean, Andrew Richards from Southweek was talking about how the technologies come on, and we got into a good conversation actually as well about things like polar patterns. So frequency response is one thing in terms of how sensitive a microphone is to certain frequencies, but obviously every mic has a polar pattern. For those that don't know, actually the space around the mic that picks up the signal. So this one has a very narrow polar pattern that pretty much is just looking forward. And so if I talk behind it, it's probably going to be a lot quieter because the microphone to pick up sound behind it. So all of this kind of stuff kind of comes into equation, whether you use kind of clusters and stuff like that. It's a really interesting topic area. But ultimately, what goes, as you said, what goes into the microphone, whether it's an engine, whether it's spoken words, it's audio, isn't it? And so really it's audio processing, applying an AI model to audio processing, to audio signal to try and derive some insight. And so how did you, because it's being used, we've seen to diagnose, or not necessarily completely diagnose, but strong signals towards a diagnosis of COVID when in a cough. I think Voca, before they were acquired by Snapchat, we're working on that, and a few others have as well. A company called Canary Speech, who can, with 3 minutes of audio, they can diagnose Parkinson's, Alzheimer's, a whole bunch of stuff. But that's being able to tell if someone's lying by listening to the sound of their voice. So how did you apply techniques to make a headway in that respect? Tell us about the whole notion of lying story.
Yes, so this was probably, and it's still an ongoing effort because it's really medically based, and so everything in medicine has to be proven through a clinical trial before it ever even be released to public. So it's been a very interesting development in the fact that we've had to do multimodal sensory fusion. So what I mean by that, and to give a brief overview of the application, is if you go into a diagnostic interview with a neuropsychologist, this application is specifically for neuropsychology right now. If you go into an interview with one of these doctors and you're trying to, figure out maybe if a person has Alzheimer's, or if they have PTSD, if they have, depression, whatever, mental disability they might have, or whatever it is, they're recording notes and they're asking a bunch of questions, right? We've seen an exceeding demand with COVID, right? Because there's a lot of people that have, it's affected our mentality so much that neuropsychologists are very overloaded with the amount of people that they're seeing. So what we did is we built a mobile application that sits on a tablet that, with the patient's permission, we ask to analyze their voice and their body track, like their skeletal tracking data, their facial expressions, their pupil constriction, and we do the same with the doctor. Now, we're not recording any data, but we're live processing it because we have to be compliant with HIPAA standards and different medical standards to actually make this work and make this something that they will accept. So we're not recording anything other than really time series data, no footage, no microphone audio, anything. But the problem, and what it's doing is it's monitoring your body language, and it's monitoring your audio for signs in which you might be a little reluctant to answer appropriately. So if a neuropsychologist is trying to drill down to really, a traumatic event in your life that may have contributed to PTSD, for example, we'll use this as an example, and you're maybe apprehensive to talk about it for very good reasons, then it's advantageous for the neuropsychologist to go back and have a report that says, hey, they might be a little bit sheepish about talking about this. Maybe, if it's advantageous and you're not pressuring them too much, you might want to maybe drill down to this a little bit more. This is one application in which you could use it, but there's several different conditions it looks for. So it's basically consolidating everything together to try to interpret emotion. So in regards to lie detection, there's certain biomarkers, not in all scenarios, but in a general scenario where you can look at to see if someone's lying. So if they refuse to make eye contact, if they they start to change their story, or their speech pattern changes, instead of talking really consistently or monotonically, they start to speed up and talk really fast, and they kind of try to avoid the subject, that kind of a thing. So that's where the natural language processing comes in. And we're tracking your eyes, right? So we're seeing if how your eye movement changes in regards or in comparison to how it was originally before we started talking about a certain topic, how you shift in your seat, any idiosyncrasies you might have with your foot jumping or anything like that, trying to kind of bring all this together to say, okay, we have evidence, or we have all this, this data from this model that has detected that they might have a tremor or something that is a pre-indication of Alzheimer's or Tourette's or something, because a lot of these conditions that are diagnosed, once they are diagnosed, it's too late. You can't catch it because they really needed to be tracked before this, or way before this, and you might be able to reverse some damage if you were to find it early, but you didn't. So it's really kind of a sad thing. So that for those conditions in which that scenario is true, those are the applications we're trying to focus on with this product, is really helping with that, trying to find Alzheimer's early, Parkinson's early, and we're starting through these diagnostic interviews because it's also we're not only analyzing the patient, we're also analyzing the doctor, how they behave, right? Because you want to make sure that there's no bias within the way the doctor's asking questions or how they're interpreting data. So you have this entire data pipeline where you have computer vision, and you have natural language processing, and you have everything coming together through this multimodal engine that's accepting different data responses to try to produce an outcome, or really try to produce a response to help advise the neuropsychologist for the next diagnostic interview. And the biggest issue with that is a couple different things. Doctors talk in a much different regard than humans do. They use prescription names, that have 20 syllables in them, they use acronyms, and they talk in a different manner in which I talk, right? And so if I go in for an interview, the natural language processing model has got to monitor, or has got to be able to recognize what I'm saying and recognize the vocabulary of the doctor. And so you really have these domains that may not even be really quite that similar, but you've got to try to accommodate for that and interpret that accordingly. Now, to synchronize these in data pipeline was very difficult because you have eye tracking data, so you have that input coming in. You have speech data, so you have that input coming in. You have skeletal tracking data, so you have that input coming in, and facial expression data. And so you have all these inputs coming in at once, in which you have to partition and synchronize, which is very difficult. So in this regard, the image processing or converting sounds into spectrograms actually helped as well, because we're able to treat everything as an image coming in, and it helps synchronize the data pipeline, because what we were finding is that the audio was being processed way faster than the images, and it was coming out of sync, right? So by slowing that down, by interpreting them as images, it helped kind of synchronize everything back up. use more compute power, which we understand, but it did help kind of synchronize everything back together to produce the outcome we needed. So I'll pause for a moment because that's I just said a lot.
Yeah, that was a hell of a lot. Tell you what I was thinking as I was listening to you talk there. I've been listening to Alan Watts lately. I don't know if you're familiar with Alan Watts. He's like this this Zen, and he talks a lot about waves and patterns, and he talks a lot about how the brain is tuned to focus on the constant and therefore miss the rest of the picture. And as you were kind of explaining, I was thinking, well, all these technologies coming together, what it gives you basically like consistent human, because it doesn't matter what you are, whether you're a new doctor, whatever you are, you have bad days, you have when you're stressed, you have days when your blood sugar's low. It doesn't matter if you're the best lie detector in the world, you miss things. If you're not a lie detector, kind of, even if you're a kind of a neuropsychologist or what have you, there might be things that you just miss because it's just one of them human traits that you just miss. Constant in front of you is the person talking, and even just listening to someone, paying attention to them talk, you'll miss body language because you're so tuned into listening to them. And so having something like this that is able to provide that level of consistency where humans are not fantastic at is fantastic. And again, it can be used in a lot of other places. I don't want to necessarily should be used for law enforcement, but you can see an application there, can't you? You know.
Absolutely. Yeah. And we have to be really careful about how this can be used because it's easy to see how this can be misused in different applications. Our goal with this is actually not to have it used in a diagnostic session like that. We're actually trying to make it so that you can have it personalized, like a personal app on your device. So we take care of our dental health twice a day, usually, sometimes more, sometimes less, but it's fair to say that most of us probably brush our teeth twice a day for 2 minutes each time, right? That's a pretty small task that we do for just our mouths. Why don't we do the same thing for our brains, right? It might be advantageous to have a mental checkup once in a while that just allows us to check in and just say, hey, we have a very intelligent model that says we see that you are consistent with the way you've been behaving before. We don't detect any anomalies. Mental health is okay. If anyone's seen a movie called Ad Astra, I think it came out like 4 or 5 years ago, but it stars Brad Pitt, and I really like this show because in there, in order for him to get off of the spaceship, he has to do a voice processing check-in. So a robot says, "How are you feeling today?" And he goes through and he just answers a couple simple questions, and it takes like 30 seconds. And they say, "Okay, voice diagnostics pass. You are okay to get off the ship. Mental health okay." And I thought, that's pretty seamless, right? It didn't take a lot of his time, and it's just diagnosing his mental health to make sure he can adequately perform his job well and to make sure he's okay. So if we can build something in a similar regard by training it in an actual professional setting, such as neuropsychologist interview, then I think that's quite great, right? We have something that can check our mental health. It's going to take a significant effort, but it's worked really well so far from what we've been able to build and acquire. But it definitely can be abused in some regards. So if we can try to, and you brought up a good point, lie detection is kind of difficult, right? And that's not always going to be accurate. I mean, we see the current lie detection scenarios that don't really work in all cases. But if we have multiple 80% solutions, and we can take if you imagine a Venn diagram, if we can take the intersection of those and say, okay, well, 8 out of the 10 things we're looking for seem to validate mental health, then we're going to consider that mental health validated or the mental health okay, then that's something we're going for. We're not going for 100% accuracy in every solution, but an intersection of all solutions in which provide individually an 80% confidence, then that's what we try to achieve.
80% enough. So finally, then, you mentioned earlier on that the kind of vision and the future state more towards the kind of general. A lot of the stuff that you've touched on has all the component parts of general AI. Computer vision, skeletal movements, natural language understanding or processing. A lot but obviously applied use case. How do you see the future of this technology, and what do you think are the challenges that you need to overcome to manifest that more kind of general application of AI?
Right now, AI addresses very narrow solutions. So, I mean, you probably all heard the term narrow AI, but we don't have something that provides a lot of intelligence. A model's got to be retrained to classify or identify vehicles, and it's got to be retrained to identify people, and it's got to and a different architecture, and it's got to be retrained to identify fruits and vegetables. Something that we're trying to aim to provide models that provide general intelligence. So what I mean by that is we can have a neural network, or in this case, let's speak about a natural language processing model that can identify different languages and identify what they're saying, right? So automatically detect what language is being spoken, and transcribe it, right? So we have a transcription of that language, convert it from English to German, and actually determine what the person is like. Actually detect the answer to a question within a stream of text. That's a pretty intelligent model that that analyzes really the entire domain space of language. If we can do something similar to acknowledge car sounds, right? Like or not car sounds, but you're going to use different audio processing modules to walk to the store to make sure a car isn't honking at you, or you don't hear a car crash next to you, right? These aren't really languages, but they're something that you should still be aware of for an intelligent being to actually function in society. So being able to have a general audio processing model would be great. That can recognize all these things and make good sense of them. Being able to have a general vision model would be great. So it can actually identify all these things with different accuracy, and actually provide intelligent responses. We see a lot of there's some efforts in this, right? Like we have YOLO object detection, which can recognize a bunch of different objects, but it's really more of recognition of objects instead of navigating. Like you couldn't ask really a YOLO computer vision model to navigate you down the stairs and to your front door. It can't do that because it's just identifying objects, maybe obstacle avoidance. But if you have a vision model that can do all of this at once, you have pretty general intelligence in regards to vision. I'm a big fan of actually trying to replicate as much. My career goal is to actually replicate or simulate consciousness. And I think it can be done, and not for the point of bringing about iRobot, but to actually understand more about how to fix anomalies in the human brain. So if we can try to provide a simulative model of the human brain that's pretty accurate, or let's just say a simulative model of the auditory cortex, just if we had a really accurate model about how the auditory cortex in a human brain worked, we could solve a lot of problems on it, because we could simulate different scenarios to say, okay, well, we know that this individual that is hard of hearing didn't lose their hearing because of this. It was because of one of these 2 or 3 events, because we simulated it on a pretty accurate computer model. That's pretty helpful, right? We can see how that would be helpful in a lot of different regards. If you extrapolate this to vision and extrapolate this to a general brain, you can run all these different scenarios that can help us solve problems within the human brain. And that might not even happen in my lifetime. That's a pretty lofty goal, because the human brain is an incredibly complex thing. But if we can zone in on maybe a few smaller portions of the brain and really try to replicate that to some regard, so we have something that that can provide intelligence onto a lot of these diseases or medical conditions that are hard to interpret, I think we're all the better for it. So really developing intelligent models that closely resemble the architecture of the human brain is the fundamental goal of Seekar and the long-term vision goal of Seekar.
Speaking of brains, my brain's been a bit blown by that, to be fair, because it is a tremendous challenge, obviously. And I think that, but hearing that your kind of philosophy on it, and seeing the actual work that's being solved in those narrow problems is a really good first step, And I think that I've heard of seeing examples of recognition for things like Alzheimer's and stuff like that. But I think the combining that technology, the eye tracking with the skeletal recognition, with all of those different things, starts to put the speech technology, which a lot of our listeners will be familiar with and comfortable with, starts to put that to new use and more practical use. One of the things of the UX world that we've been trying to explore over the last kind of 3 years really is, where does this voice technology value, and if it with other technologies and bundle together, a bit like a mobile phone, it's useful because the internet, it's got screen, it's got cameras, it's got touch, it's accumulation of a whole bunch of technologies where to solve the problem. And I think what you're explaining and the examples that you have, I think, is a perfect example of those individual AI capabilities coming together to perform better than each component could do on its own. So I think it's fantastic.
Thank you. Yes, it's a lofty goal, and it's we'll hope to just at least achieving any progress whatsoever that can help influence other companies to take the baton and move forward with it. Really, that benefits the world. So that's what matters. And if you think about, one thing that I've noticed is AI is really logic based, right? Like if we were to build a robot today, it probably would not be able to interpret emotion and understand sarcasm and understand all these different things. So you think about what goes into understanding emotion. Well, you can't just do it from speech. You can't just do it from vision. Some people argue you have to have touch to actually interpret how a person's feeling, right? So you have to have at least 2 data mediums to interpret emotion, and synchronize those together. And if it might come to a point where your phone can do that because it's got an eye and it's got an ear in which it can and a brain to process everything. And if that can kind of help interpret emotional state, mental state, that's fantastic. It's one thing that's key to that is to make sure that your data is kept on the device, because it's easy to see how if you have a cloud that knows everyone's emotions, that can get pretty dangerous pretty quick and turn into a nightmare sci-fi movie. But privacy is of paramount importance on this.
Yeah. I think it is with all of the stuff I'm thinking about. This language model being used in places is crazy. I think it can be abused to but I think that's the value of having it. Yeah, having it at the moment in a closed environment like yourselves building it. You're in control of where it's used, and so you can kind of be responsible with it. And I think that the more we kind of learn about it and the more we start applying this stuff, it's very, I think in 2018, 2017, the conversation, and certainly on the voice assistant side around ethics and stuff like that, pretty much confined to things like, is it right to have a voice assistant male? Should it be? What does that do for gender stereotypes? Should it be male? What do you do there? But I think that when you start talking about how you can use this technology to actually either manipulate people's behavior, or you can affect things on a much grander scale, as you said, as a cloud that understands how to read emotion and can make decisions based on that at an individual hyper personalized level, it starts to get very, very tricky indeed. So it'll be interesting just to watch how this goes.
Yes, I agree. Even even if we have the capability, we should always ask whether or not we should implement that capability, right? And so, making sure a lot of these newer technologies that come about are protecting privacy and preserving ethics, and really having that debate. Like I would when I was a kid, if I would have thought of robots, I would have never have incorporated ethics into the equation, right? Because you see what you see on sci-fi movies. But now that should be the first question you ask, right? Should we do it? How do we do it ethically? And how do we do it, the most in the most civil manner, really? And civil and ethics don't always go in the same boat, but if we can try to have those conversations and make sure that we develop, we don't want to look back and say AI was a good thing, but it turned into a bad thing that everyone hates, and we don't want to ever use it, right? We want to make sure it's the catalyst for a lot of good things. So, and usually starts with ethics.
Absolutely. Couldn't have said it any better. That's a lot on the table in terms of some of the things that we didn't quite get to, which is edge computing. While probably could have spoke at length about privacy and security and all this kind of stuff, but we are about out of time. But I'm definitely interested in having you along again, Kordel, as things develop, as you keep on building out this technology and find and apply new use cases to it, absolutely interested in having you back again. And I really appreciate your time, your expertise, insights. Where can people find out more about Seekar Technologies if they want to do so, and where can they reach out to you for more information and follow your journey?
Sure. So you can go to seekartech.com and learn more a little bit about most of our products. Some of them are under research, and so we don't specifically advertise those on our webpage because we don't want to give people the impression that it's a published product yet. So if you do have any request any information that maybe is something we talk about that isn't on the website quite yet, feel free to shoot me an email, Kordel@seekartech.com. We do a free consultation, initial consultation to just, observe an idea and see, if we have the capability to do it, or to just even, just to talk AI and see where, our capabilities might align with the capabilities of other people. So feel free to drop me an email or fill out the request form online. I do post a lot about our company through LinkedIn and Twitter. And I can put those in the footnotes or give them to you if you'd like. It's Kordel France on Twitter, and then also on LinkedIn as well. But yeah, I do want to thank you again for the opportunity. I'm really a big fan of your podcast, and I've actually learned a lot with it and how in ways towards natural language processing. So I really like your effort that you guys promote, and I'm an advocating listener. So thank you to you and your audience for your guys' time today.
Appreciate it. That's very nice. Appreciate that. It's definitely a pleasure to meet people like yourself and to spend this time learning with the people tuning in is an absolute pleasure. And thank everyone for tuning in. As always, next week I'll be on holiday, well-deserved break to Cornwall. So hopefully I'll be so, but I'll be or not. It's impossible to say. But we will be back the week after that, same bat time. Kordel, this has been an absolute pleasure. Really appreciate it. Definitely let's do part 2 when the time is right, because I think we did leave a little bit on the table there.
Please, yes.
Nice one. Cool. Well, thank you all, and very